Thank you, Ken. Very glad to be here today to talk about product security. Something that I have been working for a good amount of years. Until 2 weeks ago, I was serving as head of product security at Google. But let's first spend some time to talk about what we really mean about product security. Product security is the goal, the final objective, but something we will never achieve 100%. In my opinion, product security is about managing risks. And this is the reason why I would love to frame this webinar around product risk management and all the engineering efforts we could put in place to manage and mitigate this risk. Let's go deeper into product risk management. Excuse me. The real pragmatic goal is to both identify and minimize risks, and also align them to what the business is comfortable with. This is a risk tolerance threshold line in this chart. This risk bar is completely different across companies and across the stages of each company, and it varies over time. Our role as security leaders is to define this risk and prioritize them. The only thing that cannot happen is that you don't know the risk that you're subject to. In this chart, whatever is above the line, you mitigate it. Whatever is below the line, you assume it. For example, Google, my previous employee, has very low tolerance for risk and will make also big investments to mitigate the risk, while in the other hand, a startup may have other non-security priorities. Now that we're aware of the risk, we as security leaders need to plan our investments to reduce them or mitigate them. Here are some good examples. You may have a security response process in the event of an external reported vulnerability. You may want to implement a security review process to go through yet to be launched products, so you catch the low-hanging fruit before it's public to the internet. Or any other engineering efforts, things that I call investments in the future, such as framework hardening, fuzzing, sandboxing, exploit mitigations. There are tons of them. Essentially, these investments lower the risk bar and should definitely be considered. Let's briefly talk about two of them. Let's start with fuzzing. I'm a huge fan of fuzzing, an amazing approach to uncover low-hanging fruit in an automated and cost-effective manner. Cost-effective manner to uncover the low-hanging fruit again. But what about the hidden vulnerabilities? Those that they are behind several layers of checks that is going to be very, very difficult to get through fuzzing or any other means. Fuzzing is great, but it does not guarantee those to be found. And in the long run, it could be very cost prohibitive. In the same way, security reviews are great to focus security engineers on product areas we are very concerned about. These areas are usually defined by threat modeling. But again, it does not scale well, and engineers could still miss things. There is the human error factor here. These two previous efforts are great, and in my opinion, we should still invest into them. But the question here is, do we end up with this risk line around our comfort zone? Yes or no? Security leaders may be tempted to scale by throwing more engineers to the same efforts again and again, but this comes with problems. The first one, as you can see in your screen, is that the talent pool is not that big, and everyone is trying to hire from it. Every company is fighting for them. The second problem is it's not going to scale linearly as expected. You may throw a lot of engineering resources to the same problem, but the return of investment, the incremental return of investment could be minimal. Let's go back to the risk tolerance chart to explain this. If we keep investing in the same efforts, essentially the incremental return on investment will plateau and will be minimal, not to mention that these efforts could be incomplete. Instead, why don't we start thinking about some creative ways and think outside of the box? Are there any gaps in my security program? Are there any other things I could put in place? Any creative ways to scale and reduce the human error factor? These are the type of problems that excite me. These are the things that I've been working for the last years, and these are the things that I plan to work on the next years here in Semmle to try to help not only Semmle, but everyone in the industry. As you keep investing in mitigating risk, at some moment you will start thinking about open source security, right? And mainly, open source security, the security quality and response processes varies over projects, right? Product security, when we include open source, is a very tough problem to deal with. And I will hand it to Oege to go into more details about this.
Thanks very much, Fermín. Absolutely. Open source struggles to make the necessary investments in security. And I'd like to illustrate that with two particular examples. So the first one concerns GhostScript. GhostScript is a very popular utility for viewing PDF documents on many systems, in particular on Linux. Its origins trace all the way back to 1986, a time long before security was actually a thing. The originator of GhostScript, Peter Deutsch, probably had very little idea how popular his invention would eventually become. Yet, today, if you view a PDF document on a Linux system, it's almost certain that you're using his work. Now, last year, Tavis Omandi of Google Project Zero found a bunch of quite serious remote code execution vulnerabilities in GhostScript. And this meant that you could send someone a malicious PDF document, and if they opened the document, you could execute arbitrary code on their machine. And in fact, on some operating systems like CentOS, just saving the malicious file already could get you into trouble, because there, in a folder, the file viewer actually generates a thumbnail which would trigger the code execution and you'd be compromised. Now, in a well-funded environment, in that sort of situation, as Fermín was talking about, you'd expect a mature security response. Immediately, people would do in-depth code reviews and make sure that after Tavis's original report, no more problems of the same kind existed in the code base. Unfortunately, GhostScript was unable to make that investment. And indeed, after Tavis reported his problems in August, one of our colleagues at Semmle, UMO, found several more issues of the same critical severity in November. A second example occurred with the popular struts framework. So unlike GhostScript, struts was originally designed to be a widespread library for the creation of web applications in Java. And as we all know, Equifax was hit because it didn't update one particular installation of the struts package after a critical vulnerability was announced and fixed. Now, that vulnerability was actually caused by the use of a special expression language in struts called OGNL. And the problem was that untrusted user input could end up in one of these OGNL expressions, and it would be executed as code. Now, this was by no means the first problem of its kind. The same type of issue was also the root cause of several critical vulnerabilities going all the way back to 2010. So once again, you would expect that after so much exposure and so many enterprises depending on struts for critical infrastructure, all instances of the same problem would have been systematically eliminated from the struts code base. Unfortunately, that was not the case. Once again, our colleague UMO found another code injection problem of exactly the same kind in the summer of last year. In this case, the path from the untrusted input to the place where the input was interpreted as code was so convoluted and so long and complex that you couldn't really expect a human reviewer to have the patience to trace it all manually in the code by inspection. So in order to resolve this balance between security and costs, especially for open source, we need ways of automating expert reviews to eliminate not just a single instance of a vulnerability, but to eliminate a whole class of bugs all at once. And I'll hand back to Fermín to talk a little bit more about that.
Thank you, Oege. So we talked a little bit about product security, product risk management, all the different efforts that you could, engineering efforts that you could put in place. I would like to spend a little bit of time on vulnerability response, meaning what happens when an external finds and reports a vulnerability. You may have a bug bounty implemented in your company. Great first step. But what happens next when the vulnerability is reported? You may you may just do point fixes and wait for the next one, which is, at some stages of companies is the only thing that you could be doing. But this is essentially playing whack-a-mole. Or instead, what I prefer is, do you put in place a strategy? Instead of doing point fixes, you may want to eradicate the vulnerability class. Let's set as an example a SQL injection. Instead of just fixing one place, you may want to look into all your code base to look for what are the other places where I'm subject to this same SQL injection. Essentially, if you put some guarantees in your code base or as part of your processes, you could be investing in the future. This is the key important thing and message that I want you to bring home. You may want to scale through your non-security engineers. As they keep evolving the product, how do you make sure that you only make new mistakes but not previous ones? To further explain this, let's check a normal security response process. So a common response process, let's keep using the SQL injection example as a vulnerability. Somehow it gets reported to you, maybe through your bug bounty program or maybe some monitoring that detected an exploit attempt. Several things commonly happen. Someone has to triage this vulnerability. Is this bogus or is this a valid one? And if valid, commonly we work with the product team for a fix. Usually security engineers, they are not the one fixing things. The best person to fix some code base is the person that is working daily on the code base. But what about the variants, meaning similar SQL injections as we previously mentioned? You may have some engineers dedicated to this, and security engineers, and they may even find a couple more, 10 lines above the initial seed, there could be another one. 10 lines below, there could be another one. But is this enough? Did we miss anything? And more importantly, what about next day? What about when a non-security engineer keeps developing and introduces a new vulnerability? Ideally, we want to reduce to zero the time gap from development to detection. This is the gap I see as a common flaw or a common potential improvement in common security response programs. And as I previously mentioned, if we're going to have mistakes, always new mistakes. Don't commit the same thing again and again. And if we could just have solutions to this problem, this is what brought me to Semmle, to solve these things on scale, not only for Semmle, but through Semmle. And I'm going to hand it over to Oege to go deeper into the technical details about how Semmle is trying to tackle this problem.
Thanks very much, Fermín. At the core of Semmle's technology is the idea that you treat source code as data. And we have a special query language called QL for taking a seed vulnerability, a new vulnerability that you saw in the world, and find all instances of the same coding mistake wherever they may be in a particular code base, in a portfolio of code bases, or indeed anywhere in any open source project out there. The query language is designed to be object-oriented, and because it's object-oriented, it's easy to reuse the work of other security experts, and you can build on their previous attempts to create your own analyses. It's easy to iteratively improve the analysis, and that way you achieve the automated variant analysis that Fermín was talking about previously. So the query language allows you to codify your diagnosis of a problem in a readable way so that you can easily share it with your colleagues, and you can execute it so that you never make the same mistake twice. And there's a little example of such a query at the bottom of this slide. Semmle, in fact, has two products. So on the one hand, there's QL, which is intended to make security experts more effective, more efficient in finding variants of known vulnerabilities. And on the other hand, we also have a product called LDTM, short for looks good to me, to take the queries written in QL and to deploy them at scale and use them to automatically review every change as they are being made to a code base. So if we go back to the diagram that Fermín previously talked about, you have this, the standard typical security response where you take a bug, you diagnose it, and you fix the one instance of the original bug. So that's what we saw in the examples with struts and GhostScript. With QL, you can now take your diagnosis and codify it. You can codify the pattern and find variants of the same problem wherever they may be in your code base. As you're doing that, typically you will find the query can need some refinement. You want to make it more precise, more accurate, so that it reports only real problems, only true positives that you actually want to fix. Once you have a good refined query, you can then use that to monitor every change as they're being made by developers and immediately flag new variants. So on the one hand, you use QL to eliminate all the instances of the problem that currently exists in your code base, but you can then also use LDTM to flag new variants as they are being introduced so that your code base stays clean of those variants. LDTM is also engineered to make it easy to run the same analyses across an entire portfolio of code bases, so that not only do you eliminate the problem in the one in the one application, but you can eliminate them once and for all everywhere. So I'd actually like to illustrate this with a particular example. It's a vulnerability called ZipSlip. In fact, the vulnerability has been around for a while, but it was recently popularized by our friends and colleagues at SNCC, who called it ZipSlip. Essentially, the problem is that you can have an untrusted zip file coming in, and if you unpack that, you might be able to write to locations in your file system outside the intended target directory. So when SNCC announced a couple of dozen examples of ZipSlip in various open source projects, that got quite a bit of attention in the press. One of the people who took notice was a security researcher a security expert at Microsoft by the name of Dennis Levin. And Dennis wrote a query using Semmle QL to find all instances of ZipSlip in C# code bases around Microsoft. He first used the query to eliminate this problem within his own organization. But then he also took the query and he actually published it on ldtm.com. And ldtm.com is an instance of the LDTM product that's publicly visible, and it currently analyzes every commit on over 135,000 open source projects. So actually, let's go and take a quick look at ldtm.com to see how this, what this looks like in practice. So what you're looking at here is the documentation for Dennis's query, and in fact, this is the Java variant of the query. The documentation explains what the problem is. It explains how you mitigate against the problem in your source code. It gives an example and a bunch of references in case you wanted to learn more. Now, actually, you can go here to the Alerts tab and currently see all the instances that are still exist of this problem on ldtm.com. And as we can see, there's quite a few. The community still has some work to do in order to get clean of this problem. You can also open the query in the query console. And the query console on ldtm.com is, in fact, a in-browser editor where you can develop your own query. You can see the source code of all the queries that other people, including people from Semmle, but also from Semmle's customers, you can see all the queries that these people have written. And here's the query for zip slip. If we go to the very end, you see the critical structure here of the query. It takes the form from, where, select, and at a high level, what this says is we're interested in finding a data flow path from a source, an untrusted zip file, where an untrusted zip file comes into the system, to a sink, a place where you uncompress that zip file. Now, of course, that needed to be specified in some more detail, and that's in fact what happens here. Remember that I said that this is an object-oriented query language, and what this says is that we take the generic taint tracking algorithm, which is itself also defined in the query language, and you specialize it to finding instances of the zip slip problem. How do you do that? You specify what a source looks like. So this is where an untrusted archive comes into the system, and you look for a sink, a place where that archive is being uncompressed. And you also specify what it means to mitigate against the problem, so that if someone has already done the appropriate checks somewhere along the path from untrusted input to the uncompression, you don't flag that as a problem. Now, I don't want to go into all the details today, but if you're interested in learning more, in a couple of weeks, we'll be running another webinar where we actually delve into the technical details of how all this works. And with that, I'd like to hand back to Fermín to wrap up this webinar.
Thank you, Oege. I want to spend a couple of minutes talking about the zip slip thing that you just mentioned. I'm very excited not only about the technology, but also about the flexibility that comes with the technology. You can write your own, very own custom queries adapted to your internal frameworks and all these things. And also, I wanted to also mention that you can try right now lgtm.com. It's free for open source. You can just open a browser and test it right now. And the thing that I'm more excited about this is the community aspect. The fact that there was a Microsoft engineer writing this and later making it public to lgtm.com and having an impact in across all GitHub repositories is amazing. So, but let's go back into as a recap of what are the things that we covered. We talk about product security. We talk about risk threshold that each company is comfortable with. We talk about different efforts that you probably are putting in place, but over time, the incremental return of investment is going to plateau. And finally, we talk about some gaps that I personally see in product security response and variant analysis. So if you, as a security leader, you're trying to maximize your investments, this is what I would look into, variant analysis. And Semmle provides a very cost-effective way to scale and remove uncertainties. Security leaders, they don't like uncertainties. The security leaders, they would love to know if they are subject to a SQL injection or not. Semmle can provide this. And proof of this is all the nice work that Oege just presented on open source. So overall, I'm very optimistic with our approach. It's the right way to lower even further that risk bar that we have been talking about, and for any company scenario. So I want to thank everyone for your time. At this moment, Oege and I will take any questions you may have. Thank you.
I want to thank Oege and Fermín for their time this morning. And as Fermín mentioned, now's the time to ask questions. If you have them, go ahead and put them into the Q&A session. And while we're waiting for a few more to come in, as a reminder, I want to make sure you know that on July 10th is when we're going to have our next webinar, where we'll delve into more details on how QL works and how to write queries specifically around the GhostScript CVEs. So a couple of early questions came in that I want to pose back to both Oege and Fermín here. How does Semmle's QL differentiate from traditional static analysis tools?
So let me take that question, Ken. The legacy static analysis tools you could think of them as a black box. The black box contains the security expertise of one particular vendor's security team. By contrast, Semmle is an open platform where anyone can easily create their own new analyses, and many of our customers share the analysis they create with the Semmle user community in open source on GitHub.
Yeah, I would love to add a little bit to this
Right.
this notion of.
Thank you, Oege.
I would love to add a little bit of to what Oege just mentioned. Is one of the big differences that I see in Semmle's product is the flexibility. We already touched base on this one. You can adapt it to your own needs, right? There could be companies that they are writing their own web frameworks, and the source and things from external frameworks, they may not be suitable to their internal ones. So with Semmle and QL, you can clearly define those and make sure that over time there is no data flows from a source to a thing without going to some sanitization. So you can customize it to your needs.
That came in was around the sort of learning curve for QL. Like how difficult is it to learn QL and to apply it?
Okay, I can take this one. So when I was talking to Semmle probably 1 month or 2 months ago about the CSO opportunity, obviously I had to test the technology. I mean, I was in touch with the technology because of my previous employer, but I want to have a real hands-on on the technology. So I remember I was going to talk to some nice folks in Semmle on Monday, and on Sunday I started looking into lgtm.com. The goal was to, based on a vulnerability that I found in DNS mask, to develop a query that to see if I was able to pinpoint that exact vulnerability and to see if there were other variants. So the result was that after 1 hour, by grabbing things from here and there, I have a suitable query that was able to find this vulnerability, a usable query that over time it was refined, and it's something that it's going to take some time, but it's not going to take crazy amount of time. If I was able to do it within 1 hour to pinpoint a DNS mask vulnerability, I would say that there's a lot more smarter people than me that can do it way, way, way easier.
So thanks for that, Fermín. If I may, I'd also like to tell the story of a recent conference where we presented Semmle. At the Hack in the Box conference in Amsterdam, they held a capture the flag competition where one of the CTF challenges involved writing a query. Several dozen participants entered the contest, and all of them picked up QL just in a matter of hours. So a few hours investment, and you can be extremely effective finding your own variants using Semmle QL.
Thanks. Okay, we got time for probably 1 or 2 more here. So another question came in around how to measure the return on investment for QL and for LGTM. How are most of our customers doing that?
Many of our customers already have a mature security response program, and in particular, they run a bug bounty program either through HackerOne or BugRoute or indeed internally. For these programs, they have a rate card that tells you how much they would have paid in bounties if a problem was found externally. When they write a query using Semmle QL and find more variants, for each variant, you know exactly through the rate card what it was worth as a bounty, and that way they can calculate their return on investment.
Great, thanks for that. Okay, we have about 1 more. We'll do 1 more. Well, let's see if we can get 2 in here. So one question came in around whether there's any other way to access QL besides the browser that you showed via LGTM. Maybe you can talk a little bit about the command line interface and ID integrations.
Absolutely. So, of course, you can use the technology directly using a command line interface, and that's useful when you want to integrate with CI systems of your own. You can also create the queries directly using a Eclipse plugin. And indeed, many of the experienced QL writers who use it every day find that a little bit more convenient than using the editor in the browser.
Cool. Okay, we got time for one more. This one, a couple of questions came in about different languages that we support. So maybe you could talk a little bit about what's supported today and what's coming in the future.
Today, Semmle QL supports analysis of C++, C, C#, Java, JavaScript, TypeScript, Python, and shortly, it's in the works, we'll also be supporting Go. Adding a new language is simply a matter of creating a so-called extractor that takes the source code and converts it into a relational format, as well as creating a set of base query libraries to ask common questions about that particular programming language. In the near future, Semmle is planning to also add support for Ruby and PHP. However, we cannot support every programming language that anyone might be interested in. And for that reason, we are opening up the APIs so that users who would like to analyze a language for which there doesn't exist support yet can easily add their own using those APIs.
Okay, so this is a more technical question that we'll take live that Fermín can help answer. The question comes in: does Semmle come up with a standard set of signatures for common stuff like cross-site scripting and SQL injection and things like that?
Definitely. There is a public GitHub repository with all the community provided QL queries. Some of them, they are security related. And I'm going to put some examples that I was looking over the last couple of days. So as Oege previously mentioned, we support Python. So I was looking into the Python security queries, and you could put it, and there were some queries around cross-site scripting, SQL injection, deserialization of objects. And for example, let's focus on cross-site scripting. Out of the box, you are going to get queries that you are going to that they're going to look for data flow analysis from a source to sinks where they never go to sanitizers. This is a common problem in SQL on cross-site scripting, that usually you do have a get or a post HTTP variable and ends up in a response stream, HTTP response. So out of the box, there was a couple of queries that supported Flask, supported Django, and where they predefine the sources and the sinks. So you don't even need to write any queries. If you use this product, you take advantage of all these community ones that QL comes with.
Great, thank you for that. Okay, so now we are right up against the time, so I'm going to go ahead and cut it off there. If you have any additional questions, feel free to contact us. You can go to our website. You can choose an email at info@semmle.com, and we'll gladly get back to you with more information. So, once again, thank you, Fermín. Thank you, Oege, for your time, and we hope to see you guys in a few weeks on our next webinar. Thank you.